All right, today we're going to be looking at lesson 1.5. If you want to pause this and go to your textbook and find the lesson, learn the math in sections 1.5 and then come back to the video. All right, we're going to look at comparing functions across representations. Comparing functions across different representations involves identifying the key features of those functions. This includes features used to graph the function and how the function is represented in a table. Compare graphs and equations. So the first thing we're going to look at is compare the key features of two absolute values functions with f of x represented by a graph. F of x is here, and then g of x is an equation. Both of these functions are absolute value. As we can see from the graph f of x, it opens upward, and as the x values increase, so do the y values. So as the x values increase, that's increasing right here, then the y values also increase. Therefore, these functions do not have a maximum because the graph will continue upward infinitely. These functions do have a minimum. The minimum is at the point on the graph where the y value is at the lowest. Looking at the graph of f of x, you can see that the vertex is the minimum of the function. So the vertex is right here. And it says going left to right, you will notice that the graph is decreasing. So from left to right, you're going down. It is decreasing until you reach the vertex. After this point, the graph begins to slope upward. The minimum will appear at the vertex since it is a point where the function will change from decreasing to increasing. Look at the graph. We can see that the vertex of f of x is -1, -2. All right, finding the turning point of the function written as an equation is a bit more challenging, but since we know that the vertex is the turning point, we can use the equation to help us identify the point. Remember that an absolute value function, f of x equals a times absolute value of x minus h plus k, where hk represents the vertex. So this was in notes from the last section. Looking at the equation, we can see that h is 1. Negative is part of the equation here, so h is 1, and k is -3. That means your vertex is 1, -3. Alright, so you can find the vertex by looking at the graph, which we did here. So -1, -2, we came up with that by visually seeing that. And then the equation, it comes from your hk. So the 1 and -3 is your vertex from the equation. Alright, it says identify the minimum values of f of x and g of x. So the minimum value of f of x, the minimum value would be at the vertex, so -1, -2. So the minimum value comes from your y value, because remember your y is your vertical axis. So here it says y at -2, that's the lowest point, that is your minimum value. And then it says that occurs at what x value? It was at -1. Then it says the minimum value of g is, so what is the y value in g? That would be the k, which is -3. And it occurs at what x value? So again, we can just use what we've already found. H and k, remember, is the vertex. That's your lowest point. And x at 1 means you've got a y value at -3. -3 is your lowest point, but it's at 1. So you can see that these are your ordered pairs. Your ordered pairs would be -1, -2, and 1, -3. Alright, the path of a beach ball tossed across a swimming pool is shown in the graph of f of x. The path of a second ball is shown in the table. Compare the maximum heights and time in the air for the beach balls. All right, so there's the table of g of x. If we scroll down, we're going to see the graph of f of x. So g of x, we have a table, and f of x, we have a graph. So it says the path as a beach ball tossed across the swimming pool is shown in the graph of f of x. The path as a second beach ball is shown in the table. Compare the maximum heights and time in the air. So if we look at the maximum time, or the height, this goes right above 16. And if you see, this goes 12, 14, 16, 18. So halfway between that would be a maximum height of 17. Now for g of x, if we look at g of x, that's our y value, you can see it goes 3, 12, 16, 12, 3. So our maximum here would be 16. So f of x, the highest point, was a maximum. It also had a maximum for g of x. And at f of x, the maximum was 17. Okay, again right here, looking at the graph, f of x is the graph. And then the maximum of g of x was 16. And that came from the table. We're looking at the table right here as the highest y value. Alright, it says which beach ball appears to have reached the highest point. Alright, they give you a different graph here. That graph doesn't really go with this problem, so I'm going to hide it. Hopefully they'll get that changed. But it says the beach ball represents f of x has the greatest maximum height, and therefore it reaches a greater height. A beach ball represented by f of x has a greater minimum. We know that's not it. The beach ball represented by g of x has a greater maximum, and therefore it reaches a greater height. And the beach ball represents g of x. So if we go back up here and look, you know that f of x had a height of 17, g of x of 16, so f of x has the greater height. So the beach ball represented by f of x has a greater maximum, and therefore it reaches a greater height. All right, that's all for this section. I hope this helped, and if you have any